Oh, hi there. I didn't see you come in. No, I'm not going to do the entire thing like that. That would be pretty obnoxious. Anyway, yeah, just documenting my trials and tribulations, I guess, in Visual Lisp, which is the successor to Auto Lisp, in a few different CAD packages. I guess it started on AutoCAD, and then a few other products kind of took it from there. Anyway, yeah, you'll notice that I'm on an ancient copy of XP in basically a VM. It's not allowed to connect to the internet. Yeah, maybe it is. I don't know. Uh, anyway, yeah, this is just a copy of AutoCAD 2004 I got from a friend who's no longer doing drafting. So I can't justify paying, $5,000 every 3 years or whatever sort of extortion that what is it? Autodesk makes AutoCAD. Whoever they are want. It's ridiculous when you consider the price of that. I would have probably paid five figures for this program here, and in the meantime, as soon as you don't pay your life support, you're basically cut off, and the program's dead on your machine. So this is the kind of stuff that they really hate. I'm sure me being able to use something that's essentially 18 years old. It still meets all my needs. The problem domain hasn't changed for me as a woodworker or as a maker or somebody who designs and builds things. So I'm happy to sit on an 18-year-old version of something virtualized. It works just fine. So yeah, in your eye, Autodesk. You're going to force people to pay thousands and thousands and thousands and thousands of dollars and then cut them off. I don't consider that ethical at all. I think people should be able to own their software, which is why I'm an advocate in free software. Um, not that all software has to be free. I prefer it be free. But if it's gonna be something for just the average user can't afford paying $5,000 or whatever it is every 3 years. That's ridiculous. Anyway, I'll dismount my soapbox. Yeah, so I decided just to write a little program that draws a fractal. They're easy. They're relatively straightforward. So I guess I'll go ahead and do that. AutoCAD is kind of built around a command REPL that parses Lisp among other things. So I wrote this prompt tree function. I'll show you what it does. We'll do a little. Does that say truck base? We all typo. I'm not an English major. I shouldn't be expected to spell. So anyway, we'll pick the trunk base for our tree, and then we'll pick the crown base here. And maybe that tree has a little friend. In the forest, everybody needs a friend. So let's see if we can get him a little friend there. And we'll zoom in, because maybe they want their photo taken. Okay, so I'll stop being Bob Ross. Go to the extents. Okay, so anyway, yeah, you can kind of see, give me a trunk, and it basically these three lobes, is lobe the right word? I don't know, but these three fractals are basically the same, and each one splits off into a fairly less complicated version of itself. If we zoom in, you can see, it's a fractal. Okay, so let's walk through the code. Hopefully this is still recording. Doggone it. Did something break? Alright, let's try, what is it, Command and F? Did that break something? Okay, I don't know if you can still read this or not. Let's try F again to get out of this. Okay. Alright, looks like we're back alive. I don't know what the heck happened. Anyway, yeah, so this is Visual Lisp, formerly Auto Lisp. It's based on a Lisp family called X Lisp, which is about the fewest feature Lisp I've ever seen. So yeah, I think it's like goes back to the 80s, early 80s, maybe 89, late 80s. Who knows? It's like the 80s. XLisp is not necessarily. No offense to the author, but it's not a good thing. And this is built on like the oldest version of XLisp, and the drafts people are just happy to deal with it because a lot of them don't know. A lot of them don't know better, and Lisp like this Lisp is like what they consider Lisp. So I don't do their crazy trailing parentheses. That's just an eyesore that takes up extra space. But anyway, they do that and they prefer that. But I guess there's just, if you look at Lisp, there's like different kind of tribes, different schools of thought, different approaches. But anyway, before I get too far down that road, let's look at this program. So the most basic element to creating this sort of thing is a point. Basically, in AutoCAD, a point is just a list with three elements, X, Y, and Z. But my function, I have some stuff in here like this angle. I believe angle only takes 2D. So what I need to do is see if there's a third element. If so, I'm only concerned of making a list with the first and second element, and I pass that on. If there's no third element, we can assume it's a 2D point and pass the point on. Of course, that doesn't handle all edge cases of passing a one element thing in, but that does handle the case of picking points on the screen and a user being intelligent enough to enter their own points. Okay, so one of the things that Visual LISP doesn't have is they don't have, well actually there's a lot they don't have. They don't have structs, they don't have maps, they don't have vectors, they don't have objects. So basically everything's lists. It's super, super old school. So anyway, what I had to do is I had to make an associative list. Now the way you do that is you basically make a list of lists where each element has a symbol or some other sort of key. So I'm doing that a list of lists where each sublist has a key and a value. So you can see I'm just building that here. The only reason these are highlighted is because they are functions already in the IDE, and I'm using that term pretty liberally. Uh, just happens to see those as function names. Interesting tidbit. Visual Lisp, as far as I can tell, is a Lisp 1, meaning it stores functions and symbols in the same namespace. Okay, so anyway, yeah, make a line. Just make a list of lists. It's a traditional, old as dirt way to do it. Okay, and then basically after that, I wrote a little convenience function because, of course, I don't want to write cat or assoc every time I want to get a value out of one of these keys. So this does the work of that. Basically saves an S expression. And then basically what you can do is you can call any command line command from this command, which is an S expression that takes the name of the command and then some parameters after it. And there's some squirrely stuff about this. I don't claim to know all this stuff about command, but line is a command, and in the IDE if I type in, or not the IDE, in the REPL if I type in line. Now since we're at the top level here, it tries to, it lets me basically enter commands directly. So not everything has to be an S expression over here. Okay. Then after that, draw and return line. Generally, I don't like to mix rendering and logic stuff, but basically I just kind of wanted to create a pipeline where they're drawing there. Well, I'm drawing lines and passing them back through. So that's why that function exists. It's a little accessory function. Okay, then of course these branches, each one of these branches here needs to produce a child branch. And for that, it takes a parent branch and then a modified delta, which is what angle you're going to add on to it, and then a length multiplier. So if you consider the length of this to be, I don't know, let's say 42 units long, well, if you have a length multiplier of 0.5, it's going to cut that in half, and you're going to get a 21 unit long child. Anyway, this has set Q, which is kind of a gross thing. Another thing that Visual Lisp is lacking is lexical closures and lexical binding. So there is no let, as far as I can tell. So you have old, gross, C-style local variables where you basically set Q, which is define a variable, and then you have a variable value pair, as you'll see more. Like down, here's an example down here. I have a variable. I have a symbol. I should smack myself for saying variable. But I have a symbol and then a value that gets bound onto that, and it basically just ends right here. If you look, set Q, consider it a imperative style deal, like a local variable. So anyway, I'm taking a point which is the second point of the parent, which would be the end point, and from that end point I'm building a new line using this polar function, which converts it basically allows you to work in polar coordinates rather than Cartesian. So that's what I'm doing there. Shrinking it down, finding that second point, passing it to make line. And then we get into kind of the meat and potatoes of this program, which is basically this tree command. Here's an example here. You basically feed it a list of lines and it does its business. So using a generational approach rather than a recursive approach. Another thing I found out is Visual Lisp doesn't do tail call optimization, so you have to be careful. Not every Lisp does. A lot of them do. Some of them don't. Clojure is good at it. Scheme demands it by specification. Let's see what else. Common Lisp doesn't I think leaves it up to the implementation. SBCL does. I don't know if you have to set a flag on that or not, but it is safe in that way. Emacs Lisp is not tail call optimized, tail call elimination safe. It'll blow up if you recur too deep, with the exception of one of their what is it, named-let, I think was something they introduced, which does do TCO. Feeding you way more information than you need to know, but hey, I've got all the time in the world. So, let's see. Now we're saying, hey, if line list exists, as long as this isn't nil, basically, Progrin is an old school Mac Lisp, also descended deal, but just it's like begin in Scheme or do in Clojure. Basically, it just does whatever's beneath it. And the reason that I'm doing this, the reason this program here exists is because we don't have an else case on this if. We're just using the true case. Visual Lisp lets you not specify an else case. Not all languages, or not all Lisps do, but Visual Lisp does, so we're okay to do this. So we're saying if the list exists, take all the lines in the list and draw a line. And then we start into this. This is the real body of it. So we're going to repeat iterations, which is our counter. Would be like this 7 up here. But repeat iterations, and we're saying for each line in the old generation, create 3 children. And then we're saying set the new generation to the result of appending those 3 children onto the new generation. So we're building up this new generation, and we're drawing these child lines each time we loop around. And then after this for each finishes, we're saying, hey, set the old generation to the new generation and clear the new generation. So you get this behavior of you're looping over one collection, adding children and drawing them, and then at the end you basically create that as the old generation and delete out the old generation. And then here's just our prompt tree functionality. Basically, it's pretty straightforward. You have interactive functions, which are get point here. That's did it say truck over here? Wait a minute. Maybe I can't. Well, it produces a bunch of garbage. I need to see if there's a way to do like echo off or some equivalent of that. Anyway, get point has an optional base point parameter. If you don't put it in, if you don't put it in, it's just going to prompt you and ask you to click the screen like you saw for the first point. But we're doing that, and we're binding it to the symbol base point. And then I do it again, and here's the alternate form of get point. It will draw a line from whatever this is to where the user is currently pointing on the screen. So if you remember, when I first click this, actually let's go in here and I'll explain it again. We'll prompt tree again. So if you look down here, it's saying pick truck base. I need to reload this code. Apparently it's an old copy. So we pick that, and then we're in this second crown point where it's asking, pick the base of where these things start splaying out. And you can see that because we have base point in here, it's drawing this from base point. So also you can draw it at weird angles for whatever. Okay, and then it just goes ahead and hits the tree function. So yeah, this old version of XLisp that got built into AutoLisp that got converted into Visual Lisp is really, really rough. Like, I would almost say unpleasant to work in as a Lisp guy, because first of all, functions have a set number of arguments. You don't have macros, which is essential for extending the language. You don't have backquote, so you can't create list literals quite as easy. What else? You don't have arrays. Well, not true arrays. Trying to think of some of the other stuff. You don't have closures, so you can't, simulate state. You don't have lexical binding, so you don't have let. And it just gets really, really squirrely because you end up having to go. I didn't mean to do that. You have to go the long way around quite a lot, especially with this make line function. Like in Common Lisp, if I were going to do an associative array, I mean, it wouldn't even be. I mean, they have real structures, but it would be like, if I were to do this, if I were to create this list thing as an associative array, it would look something like this, and I have pt1, and I would evaluate pt1 here, and go all the way down, but because I need these to be evaluated, I have to keep using all this crap, and it's just a pain in the butt. So anyway, yeah, it was a fun little tour into Visual Lisp, and I'll probably use it in the future if I need it. If you think about hard problems in CAD, like, okay, I need a spiral staircase in 3D. I know it's this high. I know there needs to be this many steps, and I want this many turns. Well, you can pretty much write a script like this that basically works with solid objects, Boolean operations, subtractions, additions, and basically takes and builds that staircase, and then you just give it the parameters, and you're not having to sit here and draft out these crazy complex parametric things that can be more easily solved by computer. In fact, let's look at one of these and just see how many lines when I delete this. Pay attention down here into the command line. So that tree was 3,280 lines. If you were to do something like this by yourself, it could be done. It's CAD. You could do it with precision, but think of how long that would take. So if you had some need for some trees and some property, well, it's easier just to have the computer draw 3,000 some lines, and you have to sit there and work on it, or draw a big circle on a stick and call it a tree. Anyway, I think I've rambled quite enough. So yeah, it was a fun little 2-day excursion into Visual Lisp. I enjoyed my stay. I hated my stay at the same time, coming from other dialects. But I think it's a fun thing. I'd probably pull it out when I need to parametrically design some parts, especially things that I'd reuse. And I don't know. I had a lot of fun. So I guess take that as you will, and have a nice day.